Okay, so the process of balancing, what the important point is to make sure that there are the same number of on each element type on each side of the reaction. This means it'll be mass balance. We're actually observing the idea of conservation of mass. Now, there's a lot of ways to go about doing this, and the bottom line is, regardless of how you do it, you should end up with the same answer as anybody else. So it's for that reason why I say it's important that you can check your work. So let's say you do something a little funny and you check your work, you should still be able to tell whether or not the reaction is balanced. The most important thing, one of the places where people fall down on reaction balancing, is that they don't write the products or reactants correctly. So if you have the chemical formula for the compound and you write it incorrectly, then what happens is you can usually never balance the equation properly. So there's a couple of ways that you can approach this. And I always tell people one of the general ideas is just start with the most complicated thing in the reaction. That's one thing. That's this. Start with the most complicated, right? Don't break up polyatomic ions. So treat polyatomic ions as whole units. And then what we're going to do is take everything in that most complicated compound and balance it with everything on the other side of the equation. Now, wherever the most complicated compound is, right, it could be a reactant or a product. So if you have a reactant, you'll balance the stuff on the product side with it. If it's on the product, you'll balance the stuff on the reactant side with it. Now, having said that, what you try to avoid doing is trying to balance the pure elements first. For example, oxygen, O2, you wouldn't balance the pure element first because that's a fudge factor that you can just give any coefficient to get it to balance because you're not going to be affecting anything else when you do that. Also, don't worry about states while you balance because it's just a lot more writing and it'll just make your whole process neater and easier to follow. So let's go ahead and do this first one. Now, this is where that first rule that I gave about choosing the most complicated thing kind of falls on itself. How do you know what's more complicated? And it turns out you'll kind of know. It looks like it has more stuff in it. But the other thing to remember is regardless of what you start with, you should still get the same answer at the end. So just pick one and work from there. So I'm going to use this as my most complicated compound, simply because it has the most atoms in it. Now I'll also recognize that this has the polyatomic ion nitrate in here. And one of my rules is don't mess around with the polyatomic ions and try to split them into nitrogens and oxygens. This is a mistake that a lot of people make, and it's actually the way a lot of people are taught to balance equations. So this is what I'm going to do. I always draw a line under the thing I call the most complicated, and then I go about balancing everything on the other side of the equation. Now, you'll notice that this equation has two nitrates in it, and there's two nitrates in the there's one nitrate in the potassium nitrate. So what I'm going to do is use a coefficient of 2 to balance that, and that's got me going like this. Those two are balanced as a check mark. Okay. Now I'm going to do cobalt, and cobalt turns out to be easy because what? Because there's only one cobalt here and there's only one cobalt here. Remember, this subscript doesn't apply to the thing at the very beginning, only to the stuff in the parentheses. So now that I've done that, you can pick anything else and try to balance the equation. And the last thing you balance should always make everything else fit, okay? So I have a sulfur here and a sulfur there. That's balanced, so I didn't have to do anything for that. It's kind of a freebie. And how many potassiums do I have here? I have 2 potassiums, right? And I have 2 potassiums because it's K2S. So this equate. Once you do this, you know that you've balanced everything. I didn't actually have to change anything. The reaction was already balanced. Now, let's do the next one. All right. What I'll do is let you kind of decide what's the most complicated thing. And if you can't decide, use H2S. I don't know if that's more complicated than anything else, but if you can't decide, start with that. What I'll do is I'll pause it and I'll add the coefficients and we'll talk like how I got those. Okay, so there are the coefficients, right? And I started with saying, for example, oh yeah, I have H and S, right? There's two H's and one S. Well, the S's are kind of balanced, so I'll just go with that for now. And but the H's, right? There's two here, and there was only one here, so I added the two here, and that balanced my H's. So guess what? I did everything in this compound. This one's done, and now I have to just balance something else. And so what I'll do is I'll look at, for example, oh, let's see, hydrogens. There's two iodides. So that's done, right? Like that. My lithiums are done as well because there's two here. So that reaction's balanced. So I just had to add the two coefficients. Again, start with something that you think is more complicated, has more stuff in it, and then balance everything on the other side. And then you just sort of bounce around and see what's not balanced. Now check the things that are balanced with a check mark, so you know what you've already dealt with. Because if you start dealing with it again, then you're going to have to balance everything that's associated with. Okay. Now here's a more complicated one. And this is the hydrocarbon combustion reactions. And hydrocarbons are compounds containing only carbon and hydrogen. And I'm burning it with oxygen. Okay, so what I want to do is balance this. So you have to decide what's the most complicated thing. But having said that, we almost always start with the hydrocarbon. That's where we go first in these combustion reactions. So this reaction that's down here, that you see down here, this is also a combustion reaction. So we would start with this. So I'm going to draw my line under there so I know where I started, right? And then I want you to go ahead and balance carbons and hydrogens, and we'll come back and we'll have a little chat about what to do next. Okay, so I have two carbons, so I checked those off, and I balanced it because I balanced the CO2 with a 2, and then I had the 6 hydrogens, so I balanced it by putting a 3 in front of the H2Os because that gives me 6 hydrogens. And now what I'm left doing is counting up the number of hydrogens that I have. So if I look at this equation, right, I have 4 plus 3, did I say hydrogens? Oxygens I have. That's 7, okay? So think about it like this. I need to get 7 to make this balance. The only thing I have left that I haven't touched is elemental oxygen here. Okay, I don't want to underline it because that'll confuse me later, or you later when you go back to look at it. So how do I make O2 into 7 oxygens, right? Because I have an even number, and I need to get an odd number. So the way it's done, and this is kind of a trick that not all instructors will teach. So I want to show this to you, and if you want to listen to somebody else on this, fine, but this is the way I teach it. I need 7, so what I'm going to do is I'm going to go 7, and I'm going to divide it by 2. Now the number 2 comes from here. So basically, I'm going to take 7 halves, multiply it by 2, and I'll get 7. Now, having said that, right, and that gives me the 7 oxygens I need, so that'll balance like that, and that takes care of everything, and that reaction is mass balance. But when we properly balance a chemical equation, we can't have fractions, because fractions would imply like a fraction of a molecule, and we typically don't do that when we talk about chemical reactions. So what I'm going to do is, to get rid of the 2, I'm going to have to multiply everything by a 2. Now, it's not coincidental that this is happening, by the way. Right? There's a 2 here, and that's why there's a 2 here. And that's why there's a 2 here. Those always are the same thing. And then I'll get back to whole numbers when I do that. So my reaction when it's all done will be this: 2C6H6 plus 7 O2s makes 4 CO2s plus 6 H2Os. Okay? So I'll show you how to do the next one too, because this is again one of those tricky ones to think about. This is got probably the most stuff in it. So what I'll do is I'll go ahead and underline it like that, right? And then I'll say, well, I need 2 again, so I'll put a 2 here. And then I need 6 again, so I'll put a 3 here. And that takes care of the carbons and the hydrogens, like that. Okay. And so I've balanced everything except the oxygen, and the oxygen we always leave to last when it looks like that, when you have an oxygen by itself. So we won't bother balancing this oxygen with these oxygens over here. So what do I do next, right? I still have to count up the oxygen. So what I'm going to do, again, this is 4 and 3. So there's 7 oxygens, right? So what do I do? Well, here's what you do. You notice 1 oxygen is here. So I can subtract that off this total, because that says, right, I need 7. I've already got 1 in that first compound, so I really need 6 more. So I'll need 6 more. So that means I need 3, and that reaction's balanced. Right? And I can double check that, verify it, because I have 1 oxygen here, I have 6 oxygens here, and that's the same as 4 plus 3, which is my 7, right? So again, sometimes you'll have oxygen in that first compound. You don't go ahead and just balance it as you go through the first time. You wait till you get to the end and you balance it with everything else, okay? Okay, this is a tricky one. I'm going to let you guys look at this one for a moment and think about how you might balance this. So let's talk through this. I didn't just write it on here. I want to talk you through this one. This is sort of the same problem as dealing with the half up here, or the extra oxygen I need, the odd number of oxygens I need up here. It's kind of a math trick, right? 2 and 3 have a common factor there are common factors of 6, right? So I can use a 3 here and a 2 here. What that'll do is that'll give me 6 oxygens and 6 oxygens. So this is the most complicated thing, but because the oxygens don't balance, I go ahead and just cross multiply. You could have used like a 3 halves as well, and it would have still worked out. But now I have 4 chromiums here. I have chromium by itself, and so I can just put a 4 here like this. So that first cross multiplication balanced the oxygens, and then I took care of the chromiums in the next step, and that reaction is now balanced. So we're going to watch a short video, and then we'll talk about the barium chloride and sodium sulfate reaction.